In this video, we're going to look at the mathematical relationship between wavelength and frequency. So we've already seen the relationship between wavelength and energy, hopefully, on our POGIL. But here we're going to look at the relationship between wavelength and frequency, and then we'll move into energy in the next calculation. So in this equation, we see that the speed of light, which is a constant, so the speed of light is always this speed. Okay, so we're always going to use that for c. It is equal to the wavelength times the frequency. So these two numbers multiplied together have to give us c, which means if the wavelength goes up, the frequency has to go down for them to multiply and make the same number. Or vice versa, if the wavelength goes down, the frequency has to go up if they're going to multiply to make the same number. This is a pretty simple calculation in terms of algebra, so whatever we want to solve for, we can rearrange fairly easily. However, our units can be tricky. So for the speed of light, because it is 3 times 10 to the 8th meters per second, our wavelength has to be in meters. And this is rare. Wavelength is usually listed in nanometers. So a really quick conversion, if you want to change meters into nanometers, you multiply by 10 to the 9th power. And if you want to change nanometers into meters, you multiply by 10 to the negative 9th power. All right. Your frequency, which is represented by this V, is in hertz, which is the same thing as 1/second. And that unit will almost always be correct for you already. So frequency is per second or divided by seconds, which is the same thing as a hertz. So let's look at some example problems. In this first example, they want us to find the frequency of green light, and they give us the wavelength. All right, so let's see how we can solve this. I'm going to flip over to my video. We're using the equation C equals wavelength times frequency, and in this problem we are looking for the frequency. So I'm going to divide both sides by wavelength. So C divided by wavelength equals frequency. We know the speed of light is 3.0 times 10 to the 8th meters per second. And the wavelength they give us is, flip back over there, 545 nanometers. So I have to be careful with that. 545. Now it's nanometers, but I need it to be meters to match this up here. So I'm going to multiply by 10 to the negative 9th so that it can now be nanometers. Okay, and you can remember that quick conversion. You multiply to the negative 9th to go to nanometers, to go to meters, and then multiply by 10 to the 9th if you want to go back to nanometers. But in this case, it was in nanometers. I want to change it to meters, so times 10 to the negative 9th. Right? And then here, it's simply a calculation on your calculator. Our meters cancel, and our units will be 1/seconds or hertz. All right, now how do you put this in your calculator? On your calculator, you want to be able to locate this capital E button, because this is going to provide you with a shortcut. All right, so 3.0 is what we're calculating here. Whenever you see scientific notation, this times 10 part, on your calculator, you're not going to press times or 10. You're going to do EE, and you should see a single E show up on your calculator, and then you just put in your exponent. Notice I did not type times or 10 on my calculator. Okay, that will mess up your math. If you have a different calculator, we can figure out where that button is on yours, but if you'll look for this capital E button if you have a Texas Instrument calculator. All right, then we're dividing by 545, and then again there's some scientific notation. So I press that double E button, and then I just put the exponent. and then it calculates. So my answer here is 5.50, and then you have to look for scientific notation on the end of your calculator, times 10 to the 14th. 5.50 times 10 to the 14th hertz is my answer, or 1/2. What that means is that wave is passing a point this many times per second. That is really, really fast, guys. That many times per second, that's 5.50. You move your decimal 14 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So you can imagine how large this value is. Okay, that many times per second. All right, let's look at our second example. Okay, there's the way they worked it out. If you want to pause and write that down, it's a little bit neater than mine, but same thing. All right, in the next example, they want us to find the wavelength for red light, and they give us, this time, the frequency. So, we'll flip back over here to solve. I'm going to go to the back side of my paper. We know our equation is speed of light equals wavelength times frequency. And this time they give me the frequency and they want me to find the wavelength. So I'm going to divide both sides by frequency. So C divided by frequency equals wavelength. We know the speed of light is 3.0 times 10 to the 8th meters over seconds. And they give me the frequency, we'll flip back, 4.05 times 10 to the 14th hertz, or seconds to the -1. 4.05 times 10 to the 14th, 1/seconds, equals. All right, now notice your units already match because they're seconds and seconds, and so what we're going to have left is meters for our answer. So I'm typing in 3.0 EE8 divided by 4.05 EE14 equals. Notice this answer here has a lot of zeros in it. My calculator will put it in scientific notation for me, or I can count how many places I would need to move the decimal. 7.41, I'm going to round, 7.41 times 10, and I would have to move the decimal 7 times, so that's 10 to the -7th, or my calculator put that in scientific notation for me. Now that is nanometers, that is meters, and we said we can multiply by 10 to the 9th if we want to change that to nanometers. So I'm going to multiply this times 10 to the 9th, and that will be 741 nanometers. All right, so again, pause, rewind if you need to see that again. Here is that worked out. Here, they did not change it to nanometers, just leaving it in meters. And then the next thing they do is change it to nanometers. They do not show you that conversion, but it is simply a multiplication by 10 to the +9 to go back to nanometers.